Hello everyone, my name is Utkarshi Chauhan and in the previous video we had discussed about the regression modeling, and in this video we will discuss about the dimension reduction, unlocking the power of big data. So today's agenda is demonstrate how we'll identify multicollinearity Python and demonstrate how you will apply principal components analysis using the Python. Now first we understand with the help of PPT, then we move further to the codes. So first we understand dimension reduction. Simplify complexity. Dimension reduction transform high dimensional data into a lower dimensional representation while preserving key information and reducing noise. It eliminates irrelevant variables and noise, focusing on the most meaningful features, resulting in more accurate and insightful analysis. And in the next slide, importance of the dimension reduction: improved performance, reduce computational complexity and improves the speed of algorithms. And enhanced visualization makes data easier to visualize and understand, leading to clear insight. And reduce overfitting helps prevent overfitting in machine learning and models by removing irrelevant features. And now we understand principal component analysis, PCA. It is a linear transformation, project data onto a new set of axes called a principal components, and that captures the most variance in the data. And variance maximization, the first principal component captures the most variance, the second captures the second most, and so on. And the next, feature extraction, reduces dimensionality by selecting the most important principal components. And move to the another one, LDA, linear discriminant analysis, supervised approach, emphasis class separatively by finding linear combination of features that maximize the distance between the classes. And dimensionality reduction, reduces the dimension while preserving information relevant for classification. And feature extraction, and these are the application and case studies: imaging recognition, natural language processing, NLP, financial modeling, and medical diagnosis. Now, let's understand with the help of code. So, first we install the necessary libraries. This is usually pre-installed on the column, but you can uncomment if needed. So so first, first step is we import the required libraries like NumPy, Pandas, Matplot for plotting the graph, and Seaborn as SNC. These all are the libraries. And then third step is generate a synthetic data set, np.random.seed42 and n samples is equals to 100. And after that we create a highly correlated features x1, x2 and x3 and x4, strongly correlated with x1, and independent and correlated with x1 and x3. Then we combine the into a data frame. Data is equals to pd dot data frame x1 x2 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 and x3 x3 and x4 x4. And in the fourth step we identify multicollinearity using a correlation matrix plt, using the plt dot figure fig size 8,6 and snc dot hitmap data dot core function and not true cmap column for showing plt dot show function is used. And in the step 5 we calculate the variance inflation factor VIF. And in the second step we apply a PCA, standardize the data, scalar function, and x scaled is equals to scalar dot fit transform x. And then we perform a PCA using the PCA function. PCA is equals to PCA function and xPCA is equals to PCA dot fit transform x scaled. And in the seventh step we analyze the explained variances. Explained variance PCA dot explained variance ratio, and then cumulative variance is equals to np dot cum sum explained variance. And this is the plot explained variance with this. And in the second and the eighth step, transform the data using top n component example like two components, and then we display the reduced data using the print reduced data dot head. Now let's see the output of this code. So this is a correlation matrix hit which visualize the correlation coefficient between the feature in the data set. And here's we break down the, now we understand that diagonal. Now here is the output. This is a correlation matrix heat map which visualize the correlation coefficient between the feature in the data set. And diagonal 1.0 values the correlation of a variable with itself is always 1 is shown on the diagonal, and x1 and x2 perfect correlation is equals to 1 and indicating multicollinearity between this feature x1 and x4 high, which is a 0.92 suggesting significant multicollinearity, x2 and x4 high correlation 0 point again indicating, अरे यार ये वापस बोलना पड़ेगा मेरे को. So this is the output of this above code. This is a correlation matrix heat map which visualize the correlation coefficient between the feature in the data set, and the diagonal 1.0 values the correlation of a variable with itself is always 1 is shown on the diagonal, and x1 and x2 perfect correlation 1 indicating multicollinearity between this feature, and x1 and x4 0.9 suggesting significant multicollinearity, and x2 and x4 high correlation is equals to 0.92 again indicating multicollinearity, and in the x3 weak or no correlation with other variable, for example correlation near 0.19 with x1 and x2 and minus 0.21 with x4, and then features x1 x2 and x4 are highly correlated which can cause multicollinearity issues in modules like regression, and x3 appears relatively independent and does not contribute to multicollinearity. And then we move to the another one. These graphs show the cumulative explained variances as a function of the number of principal components in a principal component analysis PCA, and x-axis represent the number of principal component and y-axis represent the cumulative explained variances, which indicates how much of the total variances in the data is captured by the component. So first component capture about 70% of the total variances, and second component when combined with the first it capture nearly 100% of the variances, and third and fourth component contribute no additional variances, meaning the first two components capture all the important information. And what's the interpretation of that? This result suggests that the dataset can be reduced to two principal components without significant loss of information. So thank you for watching my video.